sometime. It's astonishing. So that is this is an empty space. See, conjecture 2 is more descriptive than 1 by the same ratio. It's more empty space than solid by a ratio of 1 second to 30 million years. And so I want you to get a feeling for this illusion that we call solidity, if you will. Now, what we discover as we start examining things, we discover that everything we run into is made up of indivisible units. Now, what do I mean by that? Let's assume I have a piece of string that's of whatever length you choose. I can cut that in half, obviously, and end up with half of what I had, right? No problem. I can take what's left and cut that in half, right? And do that again. And I can keep doing that, and you would think that I can keep doing that. It might get so small that I can't really do it. It's not, but conceptually, whatever I have left over, you figure I can cut in half, right? Wrong. It turns out I can keep doing that until I get to a distance of 10 to the minus 33 centimeters. And then I discover if I try to cut that in half, that thing is throughout the entire universe at the same instant. It loses a property that physicists call locality. It is no longer local. And they actually prove this in a laboratory experiment, that every photon is connected with every other photon in the universe immediately, faster than the speed of light. And that shatters many fundamental concepts in physics. It turns out, I've described it here in terms of length. It's also true of time. Time is made up of units. 10 to the minus 43 seconds is the unit of time. There is no unit of time smaller than that. It's very small, but there's nothing smaller than that. That's a unit of time. There's units of length, mass, energy, and time. The example is, on a violin, you can get any tone you want by where you fret it, right? It's variable. A piano gives you only the keys that you hit. You can look at it in that sense, it's digital. We discover the universe is digital. And that turns out to have some profound significance. There are two concepts that we can talk about in mathematics, but we discover don't show up in the universe. One is randomness, and the other one is infinity. Those are terms we use a lot. The infinity in the macrocosm would say that we have a universe that's infinite, except we know that we have a finite universe. There is no infinity in astronomy. We can talk about it mathematically. We can't find it physically on the big side. The shock is that we can't find it on the small side either. There's a limit to smallness. Anything you talk about, length, mass, energy, or time, there's a limit to how small, because it's granular. It's made up of indivisible units. That's what we call them quanta. Now, and so that's what so we discover that we are, and the randomness thing, there's a new field of mathematics called chaos theory. They discover that you cannot get your hands on something that's truly random. It's very elusive, and that's a whole other study. But the point is, we discover now that you and I are within a digital simulation. And that's a disturbing discovery. That what we think is reality is really a simulated environment. It's almost like a virtual game or something that we find ourselves in. Okay? So, we've talked about these. It's as if this whole world that we experience has finite limits, and it's a digital simulation. Now, it's interesting that Scientific American in June of 2005 ran an article that included this as a conclusion, that our universe appears to be but a shadow of a larger reality. Now, that's not a philosopher talking. That is the Scientific American's conclusion from the fact that our constants in physics seem to be changing. And if they're changing, maybe not much, but they imply that the real reality is something larger than we're experiencing. And wow.